Hey everyone, today we are diving into one of the most exciting physics topics, projectile motion.
Exactly, so by the end of this lesson, we will learn what a projectile motion is, how it works, and how to solve problems involving projectile motion using its formula.
So what is projectile? A projectile is any object that has been projected at some angle into the air near the surface of Earth and continue to move due to its own mass.
Think of a basketball shot like this picture. As long as the object is moving in the air and gravity is the only force acting on it, then it is a projectile.
A projectile is always in two dimensions, which means it can split into the horizontal component and vertical component.
And here's the important part. Both these components are independent of each other, which means whatever happens horizontally doesn't affect what happens vertically.
So let's start with the horizontal velocity component first. This kind of components, the horizontal velocity will always remain the same, and the reason is simple, because the gravitational acceleration always acts downward, which means there is no horizontal acceleration at all. The initial horizontal velocity will always equal to the final horizontal velocity.
So for vertical velocity component, on the other hand, it always changes, both the magnitude and the direction. As you can see from this picture, as the projectile moves up, the magnitude decreases and the direction is upwards. However, when it moves down, the opposite happens. And this happens due to gravity, which is always acting vertically downwards.
So next, we will talk about launched projectile, and there are two types of it. Horizontally launched projectile, vertically launched projectile. We will start with horizontally launched projectile first. So for horizontally launched projectile, there is no upward trajectory, as you can see in this image. And in the same time, because it lands horizontally, there is no initial vertical velocity. There is only constant horizontal velocity all the time.
For vertically launched projectile, it is important to note that at maximum height, there is no vertical velocity at all because it stops moving up, while the horizontal velocity is constant.
Next, we will look at the formulas. So for horizontally launched projectile formulas, we will need to know how to calculate the horizontal displacement and vertical displacement. The horizontal displacement just means the range from one point to another point on the same plane. So the formula for horizontal displacement will be S equal to UT. S is mean displacement, U is initial velocity, and T will be equal to time. So to derive this final formula, we will use the formula of linear motion, S equal to UT plus 1 over 2 AT squared. But because it is a horizontally large projectile, it is not affected by the vertical gravitational acceleration, which means the A will be 0. So when A equal to 0 and 0 times anything, we will get 0, we will get that the S equal to UT. And next one will be vertical displacement. And the formula of it will be S equal to 1 over 2 GT squared. To derive it, we'll use the same linear formula, S equal to UT plus 1 over 2 AT squared. But in this case, because the vertical initial velocity is 0, the U will be 0, and the A is just gravitational acceleration, so we will submit with G, which is about 9.8 meters per second squared. So 0 times T equal to 0, we will get that S equal to 1 over 2 GT squared. In short, the formula for horizontal displacement will be S equal to UT, and the formula for vertical displacement will be S equal to 1 over 2 GT squared.
Next, we'll look at the formulas for vertically launched projectiles. So, if a projectile is launched with initial velocity u at an angle theta, it must be broken into its horizontal and vertical components first. So, it will look like a right angle triangle like this. So first, to find the initial horizontal velocity, ux equals to u cos theta, because cos theta equals to ux, which is on the adjacent side, over u, which is the hypotenuse. So for the initial vertical velocity uy, uy equals to u sine theta, because sine theta equals to uy, which is at the opposite side, over u, which is the hypotenuse. Next, for the horizontal and vertical displacement, we can find them using kinematics equation, just like how we did for horizontally launched projectiles. However, next, we can also find the time taken to reach maximum height. We can find this by using one of the kinematics equations that we have learned, which is final velocity equals to initial velocity plus negative g times t. So we know that at maximum height, the vertical velocity is 0, and if we substitute that into the equation, we will be able to find the time taken to reach maximum height. However, this is only half the total time. So if we want to find how long an object actually stays in the air, we need to multiply the time that we found by 2. For the horizontal displacement Sx, we can substitute the ux with u cos theta from this equation. So the horizontal displacement equals to u cos theta times t. For vertical displacement, we can substitute uy from this equation with u sine theta. So the vertical displacement equals to u sine theta times t plus 1 over 2 gt squared.
Now we'll look at two questions for horizontally launched projectile. So the first one, a tiger leaps horizontally from a 7.5 meter high rock with a speed of 3 meters per second. How far from the base of the rock will it land? So to calculate this question, first we'll need to calculate its time of flight by using the formula s equal to 1 over 2 gt squared. So the s will be the displacement here, which is 7.5, and g, which just means gravitational acceleration, which is about 9.8 meters per second squared. So by using this formula, we will get that t will be equal to 1.24 seconds. And next, because we need to calculate the range, we will use the formula s equal to ut. So t will be the answer we just get just now, 1.24 seconds, and the u will just be the horizontal initial velocity, which is 3 meters per second. So 3 times 1.24, we will get 3.72 meters. So the tiger lands about 3.72 meters away from the base of the rock. And the second question. A rifle is aimed horizontally at a target 30 meters away. The bullet hits the target 1.9 cm below the aiming point. What is the bullet's time of flight? So to calculate the time of flight, we'll just use the same formula, s equal to 1 over 2 gt squared. However, in this case, the s will be 1.9 cm and the g will be the same, 9.8. Because the unit of gravitational acceleration is 9.8 meters per second squared, we will need to change the 1.9 cm to meter as well. So 1.9 cm will be equal to 0.019 meter. And by using this formula, we'll get that the t will be equal to 0.062 seconds. So the bullet takes just 0.062 seconds to reach the target.
So next, we will look at some example questions for vertically launched projectiles. So example 1, a football is kicked at ground level with a speed of 18 meters per second at an angle of 38 degrees to the horizontal. How much later does it hit the ground? So this question is actually asking for the total time flight. So first of all, we need to resolve the initial velocity into its vertical component. So uy equals to u sine theta, and substitute the value that we have listed into this equation. So the vertical velocity is 11.1 meters per second. And then we will use the formula t equals to uy over g to find the time taken to reach the maximum height. However, this is only half of the total time taken. So to find how long the football is actually in the air, we need to multiply t by 2, so the total flight time is 2.26 seconds. Example 2, projectile is fired with an initial speed of 46.6 meters per second at an angle of 42.2 degrees above the horizontal on a long flat firing range. Determine the maximum height reached by the projectile. So this question is asking for the vertical displacement, which is Sy. So first, to find this, we need to break the initial velocity into its vertical component. So initial vertical velocity equals to u sine theta, and we need to substitute the values that we have listed into this equation. So the initial vertical velocity will be 31.3 meters per second. And then we will use one of the kinematic equations that we have learned. Final velocity square equals to initial velocity square plus 2 negative g times Sy. So we know that at maximum height, the final velocity is 0, so we substitute the value into this equation. And if we make Sy as the subject of the formula, we can find the value of Sy. So Sy equals to 50.0 meters.
So to wrap it up, a projectile motion is just a combination of constant horizontal motion and accelerated vertical motion.
By using the formulas that we have learned, we can easily find the time taken, the displacement, as well as the maximum height reached.